Hey, okay, there we go. We're on the air. So,
Are you going to share your screen on Discord, or should I just watch the Twitch stream?
oh, that's a good point.
It might be
I'll,
faster response on
yeah,
Discord.
I will do that then. Is that all good?
Yep.
Beautiful. Okay, so I'm probably also going to upload this on YouTube just to kind of archive it. But the purpose of this is just to kind of explain some of the architecture, some of the code, some of the stuff going into Brawlback on the rollback side. Uh, this is currently June 24th, so it is very likely that things will change in the future. This is just kind of how it is now. This is the state we're in now. Yeah. So I think the first thing that we wanted to talk about was save states, which are kind of the backbone of rollback, and it's what let us. It is what lets us roll back in time and account for inputs that we didn't receive and things like that. But you know that, El Rey. So I'm just going to kind of start explaining how I've gotten some of these addresses in here. So the first point you'll want to look at if you're interested in doing save state stuff is memregions.h. Do you know where that is?
Yeah. Do you want to explain, like, at a high level, what, like, I don't know, why we're even looking at mem regions, or why don't we just back up the
Oh,
whole
sure. Yeah.
memory, for
Um,
example?
okay, so rollback netcode is what we're looking at here. That's what Brawlback is trying to achieve. And what rollback netcode does, I'll start like way at the beginning, um, is it's a way to mitigate network latency in a way that makes it so it's very hard to tell that you are lagging, I guess, is a very odd way of putting it. Um, it kind of covers up packet loss, it covers up ping, and it covers up kind of bad network fluctuations. And it does this by using these things called rollbacks. So if so basically we can kind of visualize it a little bit here. I'll do a little classic netcode explanation. So here we're local here. This is our computer, and here's the opponent's computer. And the way that rollback netcode works is that it sends inputs, basically like, are you holding up? Are you holding down? Are you holding A? Are you holding B? Whatever. It sends these little packets of information across the internet back and forth. And the catch is that that is the only thing that is sent back and forth are the inputs. There's no game state. So you're not sending, the position of the player and the animation they're in and if they've hit the opponent. You're only sending the inputs. And what that means is that your simulations, the games on both computers, must be entirely deterministic. So given the same inputs, the game must produce the same results. In theory, that's not really something we have to worry about when considering Brawl, because Brawl has replays, and you can only get replays if your game is deterministic. So hopefully, theoretically, we don't have to worry about determinism. That might not be the case. Maybe we will at some point, but I'm hoping we don't. Anyway, in order to communicate, what's going on, right? We send inputs, like I said before. But the problem is that the distance between you and your opponent can be anything from, a mile. Maybe you're playing someone in your hometown, or it could be across the world. And so these inputs are not going to get to and from your opponent on the same frame that they're sent. Right? You might be on frame 10 and you might send your inputs on frame 10, but by the time they reach your opponent might be on, frame 15. And so your inputs from frame 10 are now inputs from the past, and they don't really matter to your opponent. And so what a lot of games do is they implement delay-based netcode to mitigate this lag, which means that the local inputs here for frame 10, this client might pretend that these are frame 15 inputs. And so it'll send it, and it'll reach here, and it'll reach around frame 15, and then this opponent can use those inputs because we just kind of pretended they were from a later frame. And we do this for all inputs in delay-based netcode. So on frame 10, yeah, so on frame 10, you might send frame 15's input, or you might send those inputs and pretend they're from frame 15. But on frame 11, you'll send inputs and pretend they're from frame 16, and so on and so forth. And that kind of, those few frames of delay help mitigate this transfer time. So this is great, but obviously we introduce a delay. And so when you press the A button, right, to attack, your character is going to attack 5 frames later than they normally should. And that feels awful. So rollback netcode comes in and says, okay, we're going to do things a little differently. We're going to do this same delay thing. So on frame 10, we're still going to delay the inputs a little, but we only have to delay them a little bit. We don't have to delay them as much. And I can get into that a little bit later, but I'm going to kind of breeze over some of the details here. So we're still going to delay these inputs. We're still going to send them. Let's say they arrive on, frame 12. That's great. But rollback differs from delay-based netcode in the situation where the inputs don't arrive on time. So let's say, right, we have these inputs from frame 10. We pretend they're from frame 12. We send them to our opponent, but our opponent hits frame 13 before these inputs ever actually get there. In delay-based netcode, if your computer ever gets to a point where it doesn't have inputs for a frame, it'll just stop the game entirely until those inputs arrive. And the difference with rollback and delay is that rollback doesn't stop the game. Rollback will continue the game, but it will use inputs from the previous frame. And we have no idea if those are the real inputs that the other player put in. Chances are they are, because a lot of the times if you're going to hold A, you're probably continuing to hold A on the next frame. So we're just going to pretend like that is the case. And if that is the case, that's great. We don't have to do anything because we predicted their inputs correctly. But if they're wrong, then we do what's called a rollback, which is kind of, that's what this stuff is relevant for. And a rollback is where you just rewind time in your game. And you rewind to the frame that you didn't get these inputs. Or sorry, the frame that these inputs arrived for. So if you're on frame 13 and you just received inputs for frame 12, you would then roll back to frame 12 if these inputs didn't match your predicted inputs and use these now real inputs. So maybe our predicted input on frame 12 was like up, because on frame 11 they also inputted up. So we say, okay, it's probably that. But once we hit frame 13, we receive the real frame 12's inputs, and we realize, okay, well, that sucks. Frame 12's inputs were actually a down. So on this frame now, we have to roll back to frame 12. So we rewind the game one frame in the past. We apply these new inputs, this down. So we go, okay, that's not what we want. We want this. We simulate this frame again. We come back here. We simulate this frame. Hopefully we have inputs. If we don't have inputs for 13, then we also just use predicted inputs again. And we continue to do that. So as long as we don't have inputs for a frame in the past, we'll continue to just use predicted inputs until we receive those, in which case we'll roll back to that frame, apply the correct inputs, and then simulate back to the frame we were at before. So that's a lot. That's a whole lot of explanation, and it wasn't perfect explanation by any means. I'm not an expert in rollback, and I don't think I'll ever be, but there are a lot of great GDC talks, and there's a lot of great documentation and information, videos, blog posts, things like that on the internet you can look up and look into if you really want to figure out how some of this stuff works. But the point that we're getting to here is that a crucial part of rollback netcode is being able to rewind time, go back a frame. And in order to do that, most games will do something simple, right? Let's say you're creating a game yourself. You might have some kind of structure that holds a bunch of, player information. You might have, an integer that represents your position X and an integer that represents your position Y, right? And so in order to roll back, all you have to do is keep a buffer of a bunch of these. And when you roll back, you just say, okay, well, we take whatever the current pos X and pos Y is and all the other game state information, tons of other stuff here. We just take all that and we just apply it to the current ones. And it's very easy when you're making a game to do that if you account for it at the beginning of development. I can get into a whole thing. Anyway, so it's easy if you have the source code. But we don't because it's Brawl. We're modding the game. So what we do have access to is the emulated memory of the Wii, which is a range from, let's see if I remember it off rip. I think it's like 8 something here, and it goes all the way to 0x like 9s or something. Basically, it's something like this. We have 8s and we have 9s here. And I think in total it's about like 88 megabytes for the entire Wii memory. I think some of that is like OS stuff and things we don't really care about. And I also think about 8 megabytes of that is entirely dedicated to GameCube stuff. Playing GameCube games and whatever.
So it's not reused for the Wii at all. It's just a separate memory.
I believe so. I could be entirely wrong on that. I just remember hearing that from somewhere else. I don't have a source.
Yeah, it doesn't really matter anyway.
Yeah. So basically, we have these 80 megabytes total of stuff we worry about, minus whatever OS stuff happens. Give us about, at least from what I've heard from, I think, Bird and from some other people in the Brawl space, I think there's about 50 megabytes of like memory that we kind of have to worry about, I guess.
Right, Brawl dedicated memory.
Yeah. And the problem with having 50 megabytes of memory is that we can't just copy all of that memory back and forth every frame. So like what we had before, right, with the position X, I'm going to actually write this out really quick, just because it's nice to have. So with this, right, if you wanted to do rollbacks, you could do something really simple. You could just make a player data, something like that, and make an array of a few of them. And whenever you wanted to save state, you just memcopy your current player frame data into the buffer, or sorry, into the array, and that's literally all you do. And when you want to load state, you just take the state that you want from your array and put it back into the current one. So you might end up having like that. And so you just memcopy to and from these two things. And that's how you just do save states. But the thing is that if you have the source code and you know exactly what variables to copy to and from different places, your save state is very small because, this is only 4 bytes. This is only 4 bytes. I remember hearing, or I think I watched a GDC talk from NetherRealms, who are the company that makes Mortal Kombat. And they had a little GDC talk about their experience implementing rollback netcode into, I don't remember if it was Mortal Kombat 10 or 11. I think it was 10. I don't know. But I think one of the things he said is that their save states were like a little bit under a megabyte, which is pretty substantial because there's a lot of stuff to roll back and forth in the game like Mortal Kombat. There's a lot of game state to keep track of. Animations, effects, sounds, player data. There's a good bit of stuff. But doing a mem copy of less than 1 megabyte is still a pretty fast operation. And if the rest of your game is decently optimized or you have a pretty good computer or something, that's totally fine. The problem here is that we have 50 megabytes of save state, right? Because this is all the Brawl relevant memory. And copying 50 megabytes to and from multiple times every frame just doesn't work. It's just way too laggy.
Yeah, and we're not even just looking for some player data struct. It's all spread out because the game wasn't built to have one, singular contiguous player data struct
Yeah,
saving memory.
absolutely. So things are all over the place. We have no idea where things are that are relevant to game state or not. It's kind of crazy. So what we do is we specify specific regions of memory that we know are relevant or that we think are relevant, I guess. So if you want to work with save states, honestly, this memregions.h is really all you need to look at. This vector contains all the locations in memory that we want to back up and restore during rollbacks. And it just has a start address, an end address. This null pointer is just kind of the same for all of them. Just got to put it in there. And I kind of put this in where you put the name of the section, just so we can keep things a little bit organized and documented. And luckily, Brawl does a little thing at the beginning of a match that is very helpful. And we'll see it happen right here. So this is me with Debug Dolphin, and you can see these kinds of logs by going into, well, you can look up how to enable Debug Dolphin. Actually, I can explain it really quick right now. You just go to your Dolphin launcher thing, wherever that might be, properties, you go to this target thing, you go all the way to the end. This won't have it because this is the Lilat one, but right at the end of these little quotes, you just put a -D. And then when you launch it, it'll give you a whole bunch of cool options. So if you want to see these logs, like I was saying, you go to View, and you go to Show Log and Show Log Configuration. And in Log Configuration, you want to hit Info, and you want to come down here. And I think, let's see, this one. You want to check OS Report EXI. And I believe that's the one that'll give you at least these specifically. And these are what we're concerned about with these memory regions. So Brawl, luckily, by a bit of a stroke of luck, seems to have this system for allocating where they have these kind of memory regions already named and mapped out for us. System firmware, system effects, render first in, first out. I don't know what that really means, but rendering information, I assume. Some of these are kind of ambiguous names, but you also got like the font, stuff about menus, fighter overlays, thread stuff, replay stuff, some WePad information, I guess, sound network. So some of them are pretty named aptly. Some of them are a little weird, like info extra resource or temp. But basically, these are what I looked at initially to get an idea of the specific regions of memory that are relevant to us. And I really just kind of went off the top of my head, right? Looking at these and just kind of thinking logically, system firmware is probably going to hold a lot of like Wii stuff, right? Maybe like their information about like a network stack and like the information about like the LEDs and like SD card stuff or something. stuff that I don't think we really care about, so I totally omitted that one, and that seems to be fine. It don't think we need that. System, from what I've seen, has a lot of pretty essential stuff. I think they kind of, I don't know exactly what it's for because it kind of seems to be used in a good few places. But one thing in particular that I know is that the pad system, how the game processes, or it reads in inputs from the controller, and then it does a whole bunch of processing with them, and a bunch of the places where it stores those processed inputs are in system. So this is a pretty important memory region. Effects is, I think, just in-game effects. If I comment it out, I think it also crashes. So for both of those reasons, I've kept it in. These are pretty self-explanatory. Um, I guess not really, but they're just information about Fighter 1 and Fighter 2. There's also 3 and 4 in here. I might not show it because it's not loaded in yet. Because this is just the memory layout when you boot up the game. If I were to go into a match, it would probably be a little different. So yeah, it's not there yet. But these are information I don't think the actual like fighter's position and animation and stuff like that is stored here. I don't know exactly what's stored there, but I know it's pretty relevant. If we were to support more than a 1v1, right, free for all, that kind of stuff, we would have to put in even more regions, right? The Fighter 3 and the Fighter 4 instance, as well as the Fighter 3 and 4 resource. So that also kind of decreases performance, which is why I haven't been worrying about free for alls and stuff that much.
Hmm.
For these info resource instance and for like all this shit, I didn't really know anything about it, so I put it in, and I'll get back to this in a second. But I ran my memory diff script, and it came up that these were changed across a lot of frames. I'll explain that later, but basically, I'm pretty sure these are relevant for stuff in a match. Physics, I was getting a whole lot of desyncs without this, and putting it in fixed desyncs when like you would hit people and stuff. So there's definitely a lot of important stuff in there. I think a lot of the stuff that gets allocated there, in fact, maybe all of it, is Havoc related. So I generally think we shouldn't really touch that a whole lot, but maybe there's some room to cut it down. I'm not really sure. This overlay common seemed abnormally large. I don't really know what gets allocated there unless they literally allocate the like assets for the overlay, which I guess maybe wouldn't surprise me. I don't really know. Um, but without that, there's like crashes and weird behavior and stuff. So I kept it in, but I also kind of started doing this thing where I would take a bunch of these regions and just like chop them up. So I'd like chop it in half like I did with these fighter resources and just see if it would crash or not or behave similarly. And I ended up chopping this one into like fourths, and only the last fourth was needed to maintain non-crashing behavior. So
Oh,
I
okay.
kind of just kept it that way, and even
Doing like a
then,
binary search on which chunks of
yeah, literally.
data are needed.
Uh,
What does the word overlay mean? Do you know that?
Overlay is like I think it's kind of referring to like the HUD,
Okay.
I think, and like the timer maybe and stuff like that. It seems like there's a whole lot of memory allocated for this though, and there's also like fighter overlay stuff. So honestly, it might be something
Right.
else.
So there could be some assets in there that maybe we can figure out.
Yeah,
Like, I'm assuming there's some that don't change, but.
that's what I'm thinking. I don't know yet. Haven't looked
Mhm.
into it that much, but so yeah, that's why that's there. That was just me chopping shit up just to kind of try and get it smaller. Uh, if I don't have this WePad region in, like inputs are just totally fucked up. And rollbacks, everything's kind of boned. So I've kept that in because it doesn't work without it. And for the fighter resources, these I think I also saw some crashes or maybe some desyncs if I didn't have them in, but they're really huge. I think in my notes, hold on, let me pull this up. I think I did also post this spreadsheet somewhere. If I didn't, I'll post it in Dev General right now. But let's see. I think I had the note. Yeah, it's like 6.3 megabytes for each fighter resource, which is a lot. So I did the chopping thing with that too. I think it was also a really like there was a ton of overlay common stuff, which is why I did some
Mm.
chopping. And apparently the first half of these is what's needed for it to not crash. So I've kept it like that. And yeah, this like chopping thing is it feels kind of shitty because like there very may there may very well be data that I've chopped out that ends up causing some desync, and there's no way of really knowing that it's that region.
Mm-hmm.
So for now, I've kind of just done this to get it running a little smoother, and then worrying about it later. But
Yeah, that'll be a whole other challenge, is hunting
yeah,
the desyncs
yeah.
afterwards.
Fighter effect, I assume, is pretty self-explanatory. It's probably just the effects that get played for fighters, the little smoke, the little hit markers, all that stuff. So I've kept it in. And I believe this has like I think it was like special move variables and some information about like something like that. I don't entirely remember. I did some research on it a while ago, but I basically just figured it out like, okay, I'm pretty sure it's relevant, and I just kept it in. It's also, I think both of these are also pretty small regions anyway. I mean, this one, you can look at it, it's not that big. So yeah, I've been fine with that. Copy FB, I think, is copy frame buffer. It has a bunch of rendering stuff along with the render first in, first out. But the render first in, first out, I didn't include here because everything seemed fine without it. And if I just included the copy FB, it was fine. But I did run my memory diff script, and the only thing across like 100 dumped frames that changed in this region was this like one little section. And all the
Okay.
tests that I did, it was always just this one little section that would change. So that's why it's like that. Game Global, it has a bunch of stuff. I think this is actually where like player position and maybe some controller information and like its percent and shit, like a bunch of really essential stuff is stored here. I think the frame counter is also in here. So yeah, that's definitely needed. But that's about it. Some of these are a whole lot bigger than others. In fact, I'm gonna do something really quick. I'm gonna come into this is something I do a lot is I go into the game side repository into brawlback.h, and you can comment out these two toggles, and then you can just launch into a game normally and it won't try to like search for a match and all that. But yeah, I have a little thing in save state right here that measures each region and prints out the size of each region along with a little string, which is why I wanted to label them all so that I could see it in this nice little thing that you'll see in a second. Any initial questions that jump out? Things that I went too fast on? I kind of went pretty fast anyway, but
No, you're doing a pretty good job explaining everything. I have a question about the mem regions, but maybe I'll wait till you show this
okay.
to not derail.
So if I hop into a match, oh, I'm wrong. Okay, hold on. Because that code won't run unless you're actually in a net play match. So I'm going to do this again. Oh, one other thing I think I need to bring up is the build system. I assume the build system is working totally fine and great for you guys, right?
Yeah, I think so. I think there's a video that I'm not sure who made it, if it was White or somebody else, that goes through how to set up the build system and stuff. I think that's all still the same.
Okay.
So we should make sure to look just like that if we put it on YouTube.
True, true. because I am currently using my own build system that I had used on my repo for a while, and I feel like I probably should either start using your guys's or merge them or something.
Yeah, I think we should migrate the useful stuff into the main repo.
Yeah. Okay, here we go. So if you start up a net play match, and I can go over like setting up 2 instances of Dolphin and having them connect and all that stuff, but here's the important stuff. So we can see save state total size right now it's about 15.8 megabytes, which is large but isn't awful. And this first capture, it also has to allocate, so you can kind of ignore this number. But if you come down to some of these, like that's really bad. This one's pretty good. I actually, maybe this one's a little different. Hold on, let's scroll it down a little more. So yeah, at about 15.8 megabytes, we're looking at like around 2 milliseconds, maybe 2.5, 2 to 3 milliseconds, maybe. Yeah, hovering in like the 2 to 3 millisecond range per save state.
Do you know how long, like as a benchmark, do you know how long melee save states take to save
I
from
believe
Slippy?
melee save states are about like 7 to 8 megabytes.
Do you know how much time those take to save?
I
What kind of milliseconds are we shooting for, or is that
I
not
think theirs might be like,
insignificant?
well, okay, I know Fizzy said their frame, like simulating a frame and saving a state takes about 2 milliseconds. I don't know
Okay.
what ratio of that is saving and what ratio of that is simulating. I would assume most of that is saving.
Do you know how long it takes us to simulate a frame?
Last time I timed it, it was like 3 to 4 milliseconds for a simulated frame.
Okay.
So actually, here, let me see if I can find, I'll talk about it, but also I had this whole like thing where I measured it, and I think this is it. Maybe I should, oh, I might do that at some point. I've made a little Discord server for myself for like saving notes and stuff, but I might share that at some point because I have a bunch of stuff in here. Yeah, so according to Fizzy, melee takes about 2 milliseconds with saving state. And is this the right one or is this the wrong stuff? Yeah, okay, here we go. So frame logic. This is simulating a frame.
Mm-hmm.
4, 4, 3, 3.5, 3.2.
Yeah.
So like 3 to 4.
And this stuff we cannot optimize because that's the game code running
Correct.
on.
Yeah, so that's kind of the other issue is that not only is our simulated frames about twice as expensive, probably like 3 or 4 times more expensive than melee, but we also have more save state to deal with.
Mm-hmm.
So we have to really optimize save states ideally. Although something else to keep in mind is that these numbers, like these twos here, and possibly these other, actually, well, the other numbers maybe not, but like this two is my computer, which is a little laptop. It is a gaming laptop. It's not a weak machine, but it's also a laptop that is running 2 instances of Dolphin plus OBS plus Discord plus some other VS Code stuff.
Mm-hmm.
So if I were to close one of these instances, saving state might be a little bit faster. I don't really know how much faster, but
Can you
yeah,
test saving state on one instance?
I think I
That
should do
seems
that.
useful
Yeah.
for development.
Let's see. I think I can write it up really quickly. I don't think it'll do that just using the
Okay.
toggles.
Yeah, I meant just like if you had a way to do that to show it, but if that's not built in yet, then maybe
No, I can do it right
not.
here because you can just do util save. What is it? save state. It's current frame. So if I turn off this stuff, oh, actually, I'll probably need to bring this outside of here. Let's try that. Because, yeah, I am interested in that too. I haven't tested that in a while. But this is kind of the crux of the problem here, is making sure all the stuff in here is as small as possible, but also isn't missing any crucial data that causes desyncs. And oh, it's freaking out. That's cool. What happens if I just go in? Yeah, okay, here we go. So from like 2 to 3 milliseconds before, it's now at like 1 to 2. With just having one instance open. So this is what it would actually be in production, which is honestly pretty good. If we can cut it down to like 10 megabytes, this will probably go to like 1 millisecond average, which is honestly pretty good.
Okay. In the memregions.h, I noticed, so here you have regions that, these are regions that we want to back up.
Yeah.
Then up above, there was exclude sections.
Yep. So
yeah.
These are kind of, in a sense, they're redundant because, you could just say, oh, if you don't want to include a region, you could just manually not have it in here.
Yeah.
But there are some things that, like, it is kind of nicer to have up here. So, like, this stuff. So no matter what you put down here in this mem regions, anything that's in here will guaranteed not be rolled back. So, like, this memory range is the heap that we use for the C++ framework for the game side code. And I was having really awful bugs with random data and shit being screwed up in here. And it was because I was rolling back my own data.
Yeah.
So I had to exclude this, and then it worked. And I think this is also for code sec. Oh, so yeah, this is the heap, and these are the code sections. I don't think these are really necessary because even if we end up loading and saving these code sections, they're not going to change. But whatever.
But it's these don't. You don't have to update this every time you compile, right? Like these sections we have statically defined.
Yeah, these are all static.
Okay.
These were a bit of camera data that I had in. I don't think these are really necessary right now. I don't really know. They're still in here because I just haven't had a reason to remove them. But I was messing around with stuff where, like, because when you load state and then simulate, it can be kind of jarring with the camera if the camera just jerks to a new position instantly. So I was trying to get it so that when it would save and load state and resimulate, the camera wouldn't be updated until the very last, like, sim frame, which some people call the render frame. So that, like, the camera would only receive the new, like, let's see, how do I word this? I guess the camera, if you were to roll back, so let's say the camera's dead center, right? Camera's at 0, right here. It's looking right here. And then you roll back. So now the camera's looking where it was a few frames before, which is, here.
Yeah.
So we roll back. And then we simulate another frame. So now it goes, okay, we simulate a little bit. Now it's here. We simulate another bit more. Now it's here. Let's simulate a little bit more. And it gets back to where it was, maybe. And if it gets back to where it was, that's fine. You won't see any visual jar. But if for some reason your, player position changed, so then the camera might change, now the camera's going to be over here. And so within that frame, now the camera's going to instantly jerk back over here. And that is kind of jarring. And so I think Slippy does this too, but during rollback and resim frames, it doesn't update the camera. So it'll roll back and the camera would be here, but we don't actually roll it back here. and then it would simulate, and so it would be here, but we don't actually do it, and it would be here, and we don't actually do it, and it would be here, and then on this last frame, we actually do it. And if we do it only on this last frame, the game will interpolate up to here as it would normally over the course of a few frames.
That's actually so cool. So we're tricking the game itself to like kind of update the camera for us
pretty much
naturally to the rolled back or the resimulated position.
Yep. Okay. So that's kind of what I was doing. There's also a bit of code in game side to do that. Maybe it was in here. It was this stuff, but I think it kind of didn't work. So it is currently commented out. And maybe there was some other stuff with it. I don't know. Anyway, yeah, I hope to get back to that at some point. But that's why these are here.
So the exclude sections aren't for optimizing the size, because you're gonna have to like kind of do the processing to copy out these mem regions before you exclude them anyways, right?
Yeah, that's correct.
Okay.
So yeah, these are generally for just like if you have a little bit of data that you know is like volatile or like essential or critical, and you don't want it to be fucked with in rollbacks, you put it up here.
Yep.
And everything else happens here.
Okay.
Also, one other thing to note, I have a little comment, and it's kind of unintuitive, and I don't like it, but the mem regions have a start and then an end address, and these exclude blocks have a start and then a size. Mm-hmm. Kind of annoying, but yeah. Maybe we could rewrite it. Who knows? Okay, I think the next thing I want to talk about is related to this, the memdiff script that I had mentioned a few times.
Yeah.
So when faced with this problem of save state optimization bullshit, I was very lost and didn't really know what was happening. And yeah, because like, I mean, thinking about it conceptually, like how do you even begin to figure out what regions are relevant and which ones are not? It's kind of a really rough problem because there's very little information and everything's kind of hidden away and opaque. But one thing I did think to do is make this little script / workflow thing. I'm curious if the code is still here. Yeah, okay, it's there. So my thought was that while we're playing a game, if every frame we dump the entirety of the Wii memory that we find relevant, right? The 50 megabytes or whatever that I showed you before. In this case, probably the whole 88, because that's just how Dolphin dumps memory. And if we dump that every single frame, then take all of those dumps and diff them against each other, we can see exactly what spots in memory get changed frame to frame. And that'll give us a lot of insight into just the general regions that change, but also the very specific parts that change, like this thing, the copy frame buffer spot that I found.
Right.
So to do that, in Dolphin, in this exi brawlback.cpp, we have this save state function. And the important code for this dump process is right here. And it's commented out right now because I'm not using it. But if we uncomment it and look at what this is, do mem dump iteration, this has a whole bunch of string bullshit because I didn't want to, do anything else. Let's see, it just takes in the current number, the current iteration of the dump, which is just a static getting passed in. Probably could end up moving that in here, but anyway. It does some folder and file stuff, names it properly, and then it does these, which dump mem1 and mem2 respectively. And I believe mem1 is the GameCube stuff. I think that is wrong. I don't think it is. I actually don't know entirely what separates mem1 and mem2. But I do know that the regions that get printed at the beginning of the game that I showed before, It even tells you mem1 layout, and it has a bunch of these. Then it has mem2, and it has a bunch of these. And the mem1 is the addresses that started with 0x8. So remember before when I was like, I was up here and I said something about like they range from 0x8 something 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 to 0x9 something something something. 0x8 addresses always indicate mem1 and 0x9 always indicates mem2. I don't really know the significance of those differences or why there are two of them, but that's kind of how it be.
But they both the mem1 and mem2 are relevant for Brawl.
Yep. Yeah.
Okay.
I mean, we have system stuff here, effect stuff here, render. You know, there's a bunch of stuff in this. There's a bunch of stuff in that. They both seem pretty relevant. Where were we? Here? Yeah. So we dump mem1 and we dump mem2. And we both dump those two individual files in this little folder thing that I set up. In memdumps, dump, and then it gives you the like dump number, and then a mem1 and a mem2. And what that looks like when you actually run it. So basically, if you wanted to dump these yourself and actually use this script, which I'll talk about in a little bit, basically all you do is just comment this line back in. Actually, I think I can do this right now. Probably have these two toggled off in brawlback.h in the ASM repo. And then you'd want to build and run it. And then wait for Dolphin. Actually, I think I have in here. Yeah, I do, actually. So let's stop this. Stop. Right here. So this is basically what it's going to look like if you uncomment that line, run the game. It'll lag like hell, but you know, whatever, just play a little bit. And then if you close it out, you'll see this memdumps folder in, I forget the exact directory, but it'll probably be, it'll be in your Dolphin folder under user. So you'd go into your Dolphin, you'd go to, well, your Dolphin would look like this. Maybe you go to user, and I think the memdumps should just show up right here, or maybe in dump. I forget the exact folder. Dump index. Yeah, I think it's in dump. It would show up right in here. But it would look something like this. It'd look like a little memdump folder. You'd go in, and there'd be all these. And so this is about 89 frames worth of Dolphin memory dumps. And each one will look not like that, like this. And it'll just have a 0 and a 2. And so this mem1 is obviously the mem1. Mem2 is obviously mem2. And then it'll have a little underscore and a 0. And the 0 corresponds to the dump number, which is also in the folder name. And it won't look like that. It'll look like that. And so once you have these, you can run the script, which honestly really needs a rewrite because it's really messy and just kind of bad. But if you run diff generator.py and then pass in the path to your memdumps folder, it'll start doing some shit. And what it does is it hex dumps the dot raw, and it'll hex dump it into a dot text. And as soon as it's done with both of these, I can show you what that looks like. Actually, I'm going to let it run through this first dump iteration fully. So it'll hex dump both of them, it'll parse the hex dumps, it'll generate the diff, and then it'll move on to the next one. Generate the diff for mem2 after doing mem1.
So it's diffing the 0th frame against the first frame And then does it keep going and diff the first against the second and
Yes.
etc.?
Yep.
Okay.
It diffs the first against the 0th, second against the first, one after the other. Yep. And so this is what a hex dump looks like. It's just kind of the bytes. So this is the address, and then everything else is the bytes. And it's just all laid out like that, really nicely.
This is the same as the raw data, just
Yes.
in text format. Okay.
Yep. And so we take that text, which honestly, it would be more efficient to just actually diff the data, in binary format, but I don't have that knowledge and didn't want to look into it, so I just kind of made it into text and then did it with strings, which is why it's really slow. But it'll do that, and then as soon as it gets the hex dump, it'll compare the hex dumps and give you a diff of both the mem1 and the mem2. So these mem1 diff, mem2 diff are diffs of the first dump compared to the 0th dump. And that is why the 0th dump doesn't have these diffs.
Mm-hmm.
And this is in some kind of I don't remember what the Python library, I think it's like a built-in library. difflib. I think it comes with Python.
Yeah, it's like the same kind of format you'd get from just like a diff command line tool, right?
Yeah.
If you did diff.
.unified diff and then some strings, and it gives you whatever the heck this is. But basically, then I take those and I parse through the differences and look at this address, because these are the addresses that have changed. And if it's a mem1, I know in mem1 it starts with 0x8, and then it has all the actual address bytes. So if we just take this and put it there, that's the address that changed on this line. So I do that, and then I compile it into this file, and we have all of the changed addresses. Very cool. And the script will just kind of iterate through all the folders and do the same thing. And it'll take...
So did the script generate the changed addresses for you?
Yes.
Okay.
Yeah. And then I think the script will take these changed addresses and kind of compile it into a... I don't know where the specific line of code is, but it'll compile it into like a dictionary, and it'll do some logic to make sure... Let's see if I can find it. Yeah, I think right here. As I said, this really needs a rewrite. A lot of these names are really vague and stupid, and there's just a lot happening. So I think I would like to work on making it a little cleaner. But here you can see it kind of like goes through all the heap regions, which I think I'm calling heap info. And is this it? Okay, I don't even know my own code. That's how messy it is. But basically, it just tries to compile all of the changed addresses. If there are addresses next to each other, it tries to merge them into one memory region.
Okay.
I don't actually know if this works, if I'm going to be honest. I don't think I've tested if it specifically works. I'm giving a whole lot of vague, I don't knows, and it doesn't really work, but that's kind of how it is. I kind of wrote this in a day or two and then forgot about it. But yeah, if you want to work on safe state stuff, I think this strategy is actually a really promising one, because it really just gives you the exact places where things changed. Yeah, what's up?
Is it useful for other... Maybe, I mean, let me know if this question makes sense. Is it useful for other people to generate these dumps, or if you hosted these dumps somewhere, can we just all look at the same data? Because wouldn't multiple runs of the game give you pretty much the same types of diffs?
That's a good point. A few thoughts. The first thought is that when I first ran this exact set of dumps, you can see back here, I did this. So the reason I only have about 89 dumps is because I only dumped every 30 frames.
Hmm.
Or every 30th frame I did a dump. And I don't think that's great because I think I missed a whole lot of stuff that changed. Because if I take the output, because so this does this whole mem dump shit and it parses everything and it does things, but at the end it'll give you this file, this heap regions output, and this is the list formatted in the way that the memregions.h is of all the regions that changed in each heap region.
Cool.
And if I just plugged these in immediately, it would like instant like crash and desync, and it obviously wouldn't work. But I feel like that's because I did it every 30 frames. And if I did it every frame, I think it would catch all the differences much better.
Mm-hmm.
So I think primarily I would like to do that if you or someone else wants to work on this kind of thing, that would be a good place to start, is just not having this check and dumping every frame and then running the script on as many as possible. The other thing that comes to mind as to why I don't want just like a central repository of these kinds of things is because I feel like with different characters and different stages, different parts of memory will be changing. And so having a single dump of like Falco versus Fox on Battlefield
right
might not cover some of the regions of memory that get changed if you use like Sonic or Snake or something.
right
So yeah, I think improving this script so it's not all of this, and actually doing dumps every frame with a multitude of character combinations and possibly different stages, and then getting as many of the these things as possible and seeing if it works is a pretty good place to start. Because if you can get dumps of the game that end up giving you regions that A, handle rollbacks properly, and B, are the size of what these are, because I mean these are very specific regions of memory, and so this entire output might total like a few bytes. Maybe some of these are bigger regions, I don't really know, but if we can get it to output correct stuff, these will be very small save states, small comparatively, maybe a few megabytes.
okay.
But that
I
would
have
be
a
really cool.
question or maybe suggestion. Like, what if you looked at the what if your script found the regions that didn't change and you used that to chop up your um, existing memregions.h and then see if desyncs happen? That would be another approach, maybe.
That's a fantastic idea, and I have
Because
not
you,
thought of that.
yeah,
That is a really good idea.
because I think when you
Yeah.
end up with all those little pieces, you might not save a lot of processing power anyways if you're. I mean, I guess you can always kind of put those into bigger chunks, so maybe never mind. But
Sure.
anyways, that's a way to get around the having to test every character and stage
True,
a little
true.
bit.
Yeah, that would be a great thing to look into. I That is very interesting. Yeah.
Yeah.
One other thing I'd just like to say out loud about this, just to kind of have it out there, is that um, when you do the hex dump and when you do the diffs, like you saw before, I go here and I go here to the diff. If I say, okay, right, because what I'm doing is I'm just reading this address and saying, okay, this address changed. But these addresses are 1, 2, 3, 4, 5, 6, 7, 8 bytes. And so if I just say that this address changed, this byte might have changed, but these might not have. But with the current system, it's kind of just saying, okay, all of this changed.
Mm-hmm.
And that's kind of a fundamental flaw in what I said up here, that I may be including regions that shouldn't really be included. And so I think if I were to rewrite this script, I would want to somehow divide this up and take it byte by byte and see, okay, did this byte change? Did this byte change? Did this byte change? And mark relevant bytes like that with the correct address.
Right.
So yeah, just wanted to say that. So that's the script. That's kind of how you use it with this little memdump iteration thing. And then you get the files like we saw before. Yeah, I think that's about all I have to say.
Where is the script?
That's a good question. It's on my GitHub. There it is. I will post it in Dev General. Cool. So yeah, this strategy of diffing mem, I think, is one of the best ways to go. It's at least one of the best ways to go in my mind. Because the only other thought that I have for doing genuine research that isn't just like, ooh, I'm gonna chop this thing in half and see if it works or not, is heading into Ghidra. And I'll show you my other thoughts. Because the game, like I said before, uses those very convenient heap regions. And when it allocates memory specifically to one of those heap regions. Let's see if I can just find it by doing an alloc. So if we search up alloc, a bunch of shit shows up. Let's see if I can find it. Here it is. So GF heap manager alloc is what we want. It returns, it's basically their allocation, but you can give it a heap ID as well as the size. And it'll allocate that memory in that specified heap. And so my thought with this is that if we could just kind of look at all of the times when it actually allocates things, you know, this one allocates to the temp. This one just passes it in. This one allocates to system for whatever the heck an area manager is.
So these heap types are the same strings that, or the same labels that you showed when you were.
No, so this is an enum that I made. I don't entirely remember how I got these. I bet I can figure it out right now, though. Are you using Clumsy to simulate a poor connection? Yes. I think I'm going to talk about that in a little bit, about using the build system and setting up multiple instances and testing rollback stuff. But yes, I am. Oh, is this it? Nope. Okay, I don't really remember, but I did find something that made those heap types very apparent. It was something like the names of the functions lined up really well or something. I know I was very confident about it.
Mm-hmm.
Anyway, yeah, here's the enum in case people want to put it in their Ghidra, because I don't think I have it committed to the Brawl Ghidra, because I don't really know how Ghidra version control works. And if I did commit it, I would probably commit a bunch of other random bullshit that I've done. But yeah. Cool. I wonder if I can export this.
I wonder if you just select all the rows and columns, if it would copy and paste.
Cool. Oh, there it is.
Nice.
Cool. That is now in Discord, archived forever. So yeah, that was my other thought, and that would require a whole lot more work, I guess. But just kind of looking at like, oh, okay, it allocates sound here. Well, we don't really care about sound. What about this one? Okay, menu instance. Making string texture. I don't know. This doesn't seem all that. I mean, there's some camera stuff going on. I don't know. Iver 4 is.
So say you did find a relevant function here, like you decided that you did not, or sorry, you decided that you did want to back up this.
Mhm.
Um, like how does how do you proceed from there? Like, do you have to break while the code's running to figure out what address it's actually allocating to, or can you
Ah,
find that?
yeah, that's a good question. So I would do exactly that, what you just said. I would come here, I would break on this line, and I would just look at what the pointer it returns is. So whatever R3 is at this address.
Right. Using like Dolphin's debugger.
Yeah, yeah. The other thing I think I did try at some point was hooking into alloc itself and reading in all of the allocations for each heap. I don't remember if that really went anywhere, but that's another idea to kind of get a little bit of information. You could hook into whatever alloc functions they have going on.
Mm-hmm.
I do also want to look one more time at the memory region thing because they print this stuff out. Mem1 layout. So here's a cool thing you can do with Ghidra is because I know that they're going to print this out. I know Mem1 layout always happens. So I can go into Ghidra. I can hit search strings, just leave it with default, and then I can put that in here in this filter and then let it load for 17 years. And then it'll show me. Oh, it'll show me nothing. That's cool. Probably because 1 is a parameter. Yeah, look at that. So this is the static string in memory where they have the little printf, whatever that's called. And you can then right click on this, hit references, hit show references to address, and it'll show you exactly where they use that. And so I guess this list thing for all the memory regions is this dump list GF heap manager.
Oh,
And I remember there was stuff like
so that's how
this.
you found that. That's how you found the enum values, probably.
Oh, maybe. Actually, yes. I bet you're right. Oh no, it was right here. Wait, was it these?
Oh,
Is that right?
that helps too.
I don't even remember, man. Firmware 1, system 2. Let's pick a random one. Thread 58. Thread. God, what's 3A? 58. Yeah. Okay, yeah. So it's literally just the numbers right here.
Oh, okay.
Cool. But yeah, like get max block reset. They already kind of do some evaluation on these heaps. You can see it's like this much is used, which is like 58% capacity, and it has the address and the size and the end and stuff. And so another one of my thoughts is that if they know how much is used, that if we can go into a match and then print out this information, we can kind of figure out like during a match what percentage of each heap is used. And can we somehow from this, like how does it know how much is used? Can we figure out how much to allocate based on?
We could just chop the ends off all those heaps
Yeah,
to know that they're
exactly.
not being used.
That's another thought I had.
Are those percentages the same every time you run the game, or it's different every time?
I don't know
Oh, this
actually.
is just how much is used
Yeah, this is just how much is used at like this
at the start.
random boot
Okay.
thing. But I assume it would be same if it's like if it's this SC strap memory change thing. Here, let's look. I'll pick this one. Overlay menu is at 22% on the strap to memory change transition. So if I close it out, run it again, I assume it'll probably be the same because the allocations are all the same. Okay, so where's the SE strap? Nope. Strap to memory change, overlay menu, 22%. Yeah, so it seems like the allocations are probably just going to happen in the same order, same way. Things might be a
What's
little bit different in a match depending on characters. I don't really know though. That's just a guess.
mm,
Did you want to ask something?
um, I'm not sure. I'm just thinking.
Hmm.
Like this, what's a scene transition? So this stuff's printed on a scene transition, did you say, or
Uh,
SC strap?
this is printed on, yeah, a scene transition. So scene SC I think usually stands for strap scene. So this is like a strap scene, which I don't really know what that means, but I think it's like bootstrap. So like
Mm-hmm.
when you boot up. Memory change, this one's kind of a stumper. This happens whenever you change between scenes that are like vastly different.
Is
It's a
that like for like dynamically loading different parts of the code?
I think so. Something along those lines. Cuz like when you I don't think memory change gets called. I guess we can test this out. I would also like to comment out. Here, I'm going to rebuild and do this in a second.
Yeah, sorry if I'm derailing other stuff that you wanted to
No,
talk
no, no,
about.
it's
We
okay.
were
This is
just
this is perfect.
yeah.
No worries, no worries.
Probably more into freestyle territory at this point.
Yeah. That's what I wanted anyway. Okay. So if we head in here, so select change memory. Okay, yeah. So maybe I'm wrong still. So if we go to from the character select screen to the stage select screen, in between these two, there isn't a memory change because I guess they're loaded at the same time or something. So it transitions directly from the CSS to the stage select screen. However, from the stage select screen to there's a memory change. Oops, there's a memory change. To SE Melee, which is just like in a match, it does do a memory change because I assume it has to wipe a bunch of shit out and reallocate a bunch of stuff. So, to my knowledge, I think memory change is kind of like what you said when you have to reallocate a bunch of dynamic stuff and load in assets or something. I don't really know.
So the SC melee. Sorry. When we transition into this SC melee, this layout that it's printing below, like that's the only part we care about, right? Like what's going on during melee scene.
Yes, yes, absolutely.
So I
So,
wonder if you put a different character, would these percentages change?
oh, that's a good question. Let's try it
Because if
right now.
not, then maybe you could just chop all the heaps off
Yeah,
based on that.
I'm just gonna do a classic. Go to Notepad, and then I'm gonna give myself much time. Actually, can I? Oh god, do I have a bound? I don't. Okay, never mind. Because then, yeah, we could just chop off the ends, and that would be great. Oh, I also have items turned on accidentally. Okay, so I'm gonna change to like Snake and maybe Ices. Some like weird characters that might load some shit.
Mhm.
And let's go to Battlefield instead. Okay. So memory change SC melee. So this is the one that we want. Let's grab this. And then let's do this cool tool. Yeah, trial version. And I'm going to do a text compare. And I'm going to throw this one in there. Put this one in
There's.
there. And it fucked up. Well, hold on.
Oh.
Let's see. How do I think I have to do like this maybe? There we go. Okay, so yeah, the system has slightly different allocation. So does effect. It's like very slightly though. The fighter overlays are significantly different for some reason. 40 here, 90 here.
Yeah, tough to touch any of the ones that are changing because
Yeah.
we
The
never
fighter
know.
resources were pretty significantly changed, which makes sense, I guess.
Mhm.
Ices and Snake and whatever. Same with these resource twos.
Yeah, I see Snake's 97%, right?
Yeah.
Is this the second fighter one?
Snake is player one, yeah.
Kind of makes sense.
Does.
Why'd your network jump to 66%?
That's a great question. I have no idea.
Okay. It's weird.
Maybe they do extra. I don't know.
Yeah. But there's a lot. It's, I guess anything here that's 0, we probably know we can throw away, but you probably already figured those ones out.
Yeah, I think so. I know the fighter instances are necessary. It does say 0 though here, which is interesting.
Oh.
I wonder if I actually just comment those out, because honestly, I'm not gonna exit up yet. Here I am. I've only kept those in because it seems so like obvious that they should be in there, but maybe they're actually not necessary. And I'm gonna turn these on.
Yeah, one thing that I feel like I don't really understand is it says at the start of the match how much of those heaps are allocated, but what's to say? I was about to say what's to say it's not allocating during the game, but I guess the game would be coded in a way to not do allocations during the game, specifically for performance reasons.
Yeah, I would
Right?
think so. Hmm. But yeah, if we don't need the 2 fighter instances, that'd be sweet. Because I think those are pretty sizable. Oh, that is one other thing I want to bring up. Okay, I'm gonna go here. Put you in. Put you in. Okay, let's see if it instant desyncs. It certainly might. But if it doesn't, that'd be cool. Oh. Yup. Classic.
Okay, so the 0% is misleading. Clearly, there's some memory being used there.
Indeed.
That needs to be. Okay.
So one thing I did want to talk about that I reminded myself of just now is in this printout stuff, it gives you a very exact amount that each of these takes up. And so stuff like system, which is 0.3 megabytes, it would be nice to optimize that, right? 0.3 megabytes is somewhat sizable, but in the face of like this info extra resource or the two fighter resources, it's
Mm.
not very significant. And so these three info things, as well as the two fighter resources, and actually, I guess I don't really remember the fighter instances. Those might be kind of sizable too. But looking at this kind of gives you an idea of what you need to optimize, right? Like if you were to look into the Wii Pad stuff or like the effect stuff, it's like we don't really care about that a whole lot. This overlay common is this is a fourth of it and it's still 1 megabyte, so it was very big before.
Yeah.
So yeah, that's all I wanted to bring up is just using this little printout stuff to figure out which regions are huge and which regions you don't really need to care about.
Yeah. Don't spend weeks trying to figure out how to optimize the tiny
Exactly.
ones.
Yep. Cool. Okay, so do you have any other nagging questions about save states in particular?
No, like I wrote down some main ones, but pretty much we covered them off. Like, how do I test a change? We kind of talked about, like, you have the performance printouts to show how long it takes to back up the save states.
Yep.
That's the main thing we want to know. Is the time it takes to save a save state going to be pretty much linear with the amount of time it takes to roll back a save state?
Yeah, they're
Like,
identical. They're just mem
okay,
copies, but
yeah,
one is one way, one's the other way.
okay. And then the way that, so that's how you would test kind of how well your memory pruning is going. But then
Yep.
then if you want to see did you cause a desync, you need to launch the two instances and
Yeah, you kind of just need to launch it and like fucking mash buttons for a few seconds.
so what causes a crash versus a desync, or is that kind of just not an easy
Yeah,
question to answer?
I have no idea. Like, I mean, commenting out the fighter instances like we did, and it gave a crash. I have
Yeah.
no fucking idea why. Like, I, who knows? And like, having physics commented out cause some desyncs when you hit other players. That kind of makes sense, right? You kind of need some of the havoc stuff to make sure things are working between player interactions.
So do you only get a crash or a desync if a rollback occurs?
Typically, yes, but I have, yeah, I would say, well, yeah,
Because
because I mean,
that's all this is being used for. Is
yeah,
for
it's just during when you're
um,
actually loading a save state and when you are, well, yeah, that's it.
how are you forcing Dolphin to load a save state when you have two instances sitting on the same computer with no network latency?
How am I doing it?
How are you forcing rollbacks to happen?
With Clumsy. It's a
Okay.
very small little application where you can put in a rule up here, and I can also put this in Dev General. Schlump. Where you put in a rule, and this is just like stuff about the ports and the like what traffic you want to apply this to, and it can create artificial lag, it can artificially drop packets, it can do a whole bunch of bullshit. Um, but yeah, I have it set to uh, simulate 35 milliseconds of ping on both sides, which ends up kind of being like 80 to 90 ping because there's some weird fluctuation algorithm it uses. So like here, if I start it, and thankfully because we can do these port things, if I start it, at least hopefully, it won't affect other shit on my computer. It'll just affect
Yeah.
uh, the Brawlback stuff. So if we run it again now that we have the fighter instances back, it doesn't crash. But yeah, so I use this for simulating lag and maybe also simulating some drop packets. Um, but otherwise, I also did make a little thing. I don't even know if it's still here anymore. I think I got rid of it. But I also did have a little thing that you could also probably do, um, where I would just like, oh fuck, I hate this window because sometimes I click, and if I click in the window, it just stops.
Yeah, I don't know
I don't know
why
why
it does
that
that,
is.
but I've been frustrated by that many times. Yeah, because
Um,
you could go into your ASM code and just make it roll back every frame, no
yep,
matter what, right?
yep. So I did have that. I don't know what happened to that code. I
Mm.
guess I got rid of it for some reason. I don't see it anywhere, but it's certainly in a commit somewhere. If you really do want to just copy and paste it, but otherwise, I think that basically what I did is I just like if frame mod some like random number or something, or maybe I set it to like a static number. You could just do like every 10 frames, every 5 frames, just do a rollback, which would be, I guess I don't have a util function for that, but you'd basically just do the exact same thing as this, load state, but then it'd be command load current frame, boom. There we go. So maybe I'll commit that, but you just call this to load state. And then to, oh, actually, with the new architecture, I don't know. Well, no, you could just do that. Hold on 1 second. So yeah, I guess if you wanted to trigger manual rollbacks, you would have to change this frames to advance variable, which is in here. So you just kind of be like, oh wait, actually, do I have a set? Yeah, you just be like this and then say, okay, 5. So I might load state for the, do I have the current frame? I do. Current frame minus 5, and then set the frames to advance to 5. So it'll roll back to 5 frames previously, and then make sure that we simulate 5 frames now. Or maybe you want to do 6 frames to catch up to where you are. I'm not really sure. But basically, that's what you
Yeah.
would do.
Yeah, you just add that in, it'll do it every time.
Yeah, and that could be another way to test it if you don't want to have to use the networking stuff every time. But that,
Yeah, and it's like a stress test for performance too, right? Because you gotta.
yeah, exactly. But do keep in mind that you wouldn't really be able to see, well, you wouldn't be able to see desyncs because if you're just testing it right here, there's no remote client to desync with, so you could test the performance that way and to test if it doesn't crash. So that's a great way of doing that, but you wouldn't really know if it desyncs stuff.
Oh, right. You're just rolling back to your local state.
Yep.
For no reason. Gotcha.
Yeah, exactly. Okay. I think I think the two things I want to do is I do want to explain just the kind of overarching architecture of how inputs flow from your client to the remote client and all that stuff. And then after that, I think I want to talk a little bit about uh, different Dolphin instances and at least my build system and stuff like that.
Cool.
So, yeah, I guess I will just start here. So the first thing that we do is this thing right here. And actually, I'm going to pull this up in Geezer because it's really nice to visualize the loop here. So this function is pretty important. Main loop sub, this is where the actual Brawl game loop happens, right here. So this do while loop, this is the Brawl game loop. All true. It does everything. And the extra special super important part is this for loop right here. So this for loop, and I have some labels on it, so it's pretty obvious already. but this for loop simulates frames of the game depending on this variable. And this, coincidentally, is actually exactly where I hook up here, where I load. This is the disgusting inline ASM syntax where I load this frames to advance variable into R24. And you can see here that you can't really see here, but there we go. So this frames to simulate, this is R24. So it compares R24 to whatever this R19 is, which is basically, I think, this uvar5. So whatever's in R24 here will be the number of times this for loop gets run. So we can control this variable right here with this. So where was I going with this? I think that was a bit of a tangent. I'm actually going to back up a little bit. Because we have this game loop, I have kind of two important places, which is right here and the stuff I said before, which is the for loop. And right here, it's like the Brawl devs wanted to give us a great place to do it. I just hook inside this cute little function and use that as kind of the pre-frame, is what I call it in my head, which is this. So this is inside begin frame logic, which is this. And this function is only called, right here at the very beginning of the game loop, right, for these two things, but I don't think these two things matter very much. And so this code runs at the very beginning of each frame, and we can see it says, okay, it gets the current frame, which is just kind of there's a static struct here and it has a frame counter. So we can grab the current frame, we check if we're in a net play match, which basically just signifies, right, have we matched with a player? Have we, is this a match that we actually care about for net play? Ideally, I'd like to separate, net play and non-net play matches so that you can play offline with the launcher. So this is kind of what that check is trying to do. It does some stuff with frame advance and rollbacks. I don't really care about that. I'm not going to explain that much. But this is the important part, is that if we have the net play toggle on, it'll call this. It's kind of a redundant function, but whatever. And it will take the current information that is relevant for each player in the match and write it to this frame data struct. And it'll then send the frame data struct over to the emulator. And so this populate thing, it writes the frame, it writes the player index, it writes our current inputs, which is again just a static struct, and we grab the pads and then we convert it into this other struct. You can look at that if you want. Basically, we get the inputs. We get a whole bunch of other information, which currently is unused, but my current focus is working on desync detection and being able to like display a message to show that you're desynced. And this information is how I want to do that. Because generally, if you desync, one of these things is almost guaranteed to be different, right? If you desync, you're almost positive, like it's almost guaranteed that your location or your position, whatever you want to call it, is going to be different. And so just comparing these is enough to really detect most desyncs. So we write all that information into this player frame data, which gets written to this frame data, which is just an array of 4 of them. And then we send it up to the emulator. And on the emulator, we receive it right here. Handle local pad data. So this data is a pointer to this frame data that we sent. So we're just doing this thing. We copy the data into this frame data struct, and we're doing it in this way because we had a bit of a conversation, and the compiler can do some cool stuff, I guess, if you memcopy it like this and use a stack thing instead of just going like frame data equals frame data pointer data and then dereference instead of just doing like that or something.
Ah, it's scary.
I guess this is a better way. So yeah, we now on the emulator have this information from the game. And the first thing that I want to do with that is swap the endianness, because any information that you write or use on game side is going to be, I wonder if I'll mix this up. I think it's big endian on the Wii.
Yes.
Okay, yeah, cool. It's big on the Wii and little on most modern systems. So we need to swap the endianness of all of our data structures and all the information when it comes from game to emulator and emulator to game. And there are nice little swap endian functions here. It's not too complex. You can look up endianness online. You can look up swapping endianness. There's tons of resources and stuff. It's a generally common problem with embedded stuff and with PP. Yeah, it's definitely a look-upable thing. But anyway, the frame data, so the inputs and stuff come here. We do a bunch of shit that doesn't really matter right now. We check if our client is synchronized with the other one or is generally in a similar position. If one computer is lagging a whole lot and the other one isn't, things are going to drift. So one client might be on frame 10 while the other is on frame 20. And if we get to that point, that's a really bad situation. So this kind of helps clamp the, I guess, clamp the frames of both clients to a reasonable limit. So if one gets way, way ahead and the other's way behind, it'll make the one that's ahead pause for a few frames to let the other one catch up.
Quick question on that. Like what I thought of when I saw that code. So in a rollback setting, you have like a pre-programmed amount of delay frames that you're allowing for.
Yep.
To like collect save states, then roll back to them.
Mm-hmm.
So this time sync is like that should only happen in the absolute worst case, right? That you don't have inputs for the past 7 frames worth of time.
Yes.
Or whatever.
Yes, that's
so like
perfectly
in like
correct.
a good match, like where your ping is reasonable and not spiking, this code's not really hit. But this is kind of like the if all else fails, like you're probably not gonna be having much fun if you're time syncing a lot, right?
Yeah, absolutely.
Okay. It's
Yep,
more
yep.
of like a worst case type of thing.
Yes. It absolutely is. Because, yeah, if there's a huge ping spike and you don't get inputs for, 7 frames, it'll predict for, I think right now, I have to go and find the file. It's right here. I have 5 rollback frames right now. So, if you don't receive inputs for 7 frames, it'll predict for 5 frames, realize we still don't have inputs, and be like, ah, damn. Okay, if we continue to predict for a 6th frame, we won't be able to roll back enough to resynchronize things. So we just stop. And yeah, that's what some of these functions in the time sync class handle. But one other thing, I guess it doesn't always, that's mostly what the time sync stuff is for, but also there is slight drift sometimes, right? If you're lagging slightly more than your opponent, things do just kind of drift naturally around and get out of sync. So every, whatever this is, every 30, I think Slippy also has 30. So every 30 frames, we do also just check to make sure, are you reasonably synced up? And if you're like, this is just copied pretty much straight from Slippy. If you're over 60% of a frame ahead, we just kind of stall you for a frame. But this only happens every 30 frames. So if you are consistently drifting, right, if one computer is very significantly less powerful than the other one, and the other one is handling the game like 60 frames locked perfectly fine, then you'll be reduced to like 58 frames per second, right? Because we time sync every 30 frames, so that's max 2 per 60 frames. So generally,
right,
this won't get hit a whole lot, but it also
this
might.
is to handle the case if one person's computer is not hitting the 60 frame rate,
Yes.
60 FPS target, then it'll still work. It just won't feel good.
Yeah.
Or if you miss one frame time, right? It might still feel good. It's just
Yeah, yeah. Generally, you can't really get away from having to stall every once in a while.
Mhm.
Slippy is really good at this and barely stalls at all unless you have terrible ping spikes or something weird happens. But that's mostly because Melee is such an old game and their game simulations are like the simulating a frame of the game takes like maybe a millisecond, maybe less on most modern computers. And so pretty much everyone can run that game perfectly. And as I've been kind of experimenting with Brawl, I get the feeling that like you won't be able to run Brawlback smoothly on a potato PC for sure.
Mhm.
And even if people come up with like Diet Brawl and like those kind of texture packs, I kind of feel like this is just generally going to be an experience that you need a pretty decent computer to run well.
Yeah, your core game loop isn't going to be affected by those types of mods,
Yeah,
right?
exactly.
And your save state size.
Yep, yep. So yeah, that's time sinks. If you want to learn more about that, that's a pretty like common thing that pretty much every game in existence does for multiplayer. You can look up clock drift. You can look up time sync. Actually, there's a really great video. I can recommend one right off the bat. Or actually, I can recommend a YouTube channel for rollback stuff. Let's see. His name is Zinak or Zynak. Here it is. So if you look up Zynak on YouTube or Zinak, however you want to pronounce it, this guy, he has a series where he just explains a bunch of shit about rollback and fighting game netcode. Specifically, at least the one that I was thinking about, um, clock synchronization stuff. He just generally has a few videos on a bunch of these topics, and they're pretty decent videos. So if you want more content, Zynek is a guy to watch. So yeah, anyway, moving on. Um, Once we get these inputs on the emulator, we pretty much just do two things here in this like pre-frame stuff in the begin game logic hook. We just store them in a local frame data buffer and we send them to your opponent. And that's pretty much all we do. And so after that gets run, so right at this point we take all of our local pad info or frame data, whatever you want to call it, we store it and we send it to the opponent. And then a bunch of this shit happens, whatever, don't really care. And then we hit this. And what this is doing is it's going to hit this thing first, which is right here. And it's going to say, okay, we have a hook here, we branch here, okay, we go here, okay. So this is basically requesting from the emulator the number of frames that we should simulate on this frame. And I think I'm going to start calling them something a little different so that I don't say frame every single time. This for loop, these frames, these are like simulated frames. So these are frames that are run without rendering. And all this stuff at the bottom, GX3, render, this is like the end of a frame where it's actually rendering the frame to the screen. And this kind of whole do while loop, I kind of call this render frames. So that's kind of an important difference between simulated and render frames, where the simulated frames don't render to the screen and the render frames do. The user only sees rendered frames, but we can roll back and resimulate a bunch of simulated frames or simulate. What do I call it? Fuck. I'm tired. Uh, Yeah, simulation frames versus render frames. Did that kind of make sense, or did I stumble over everything?
Um, yeah, I think that made sense. Sorry, I was a little bit tuned out for that part, but
You good? Yeah. So we come here, we say, okay, emulator, how many frames should we simulate right now? The emulator says, well, it's whatever's this frames to advance variable, which is just in this big class here somewhere. There it is. So whatever's in here, it just gives it right back to the game. And we put it directly into this one, which is the one that gets read in here, into R24.
yeah.
So all that was basically saying that this frames to advance variable on the emulator controls the number of simulation frames to run on this render frame.
And in other words, it's how far should we roll back on this frame, right? Is
Other
that
way
another
around,
way
it
to
is
word
how
that?
many frames to simulate. So
But if the emulator says you need to simulate 5 frames, doesn't that mean roll back to 5 frames in the past, then simulate 5 frames? Or
not
am I a
necessarily.
bit lost here? Okay.
So rolling back and simulating are two separate things.
Mhm.
Generally, obviously, they happen in conjunction because that's just kind of how things work. But you call, I guess I could say it like this: you call two separate functions to rollback and to specify the number of frames to simulate. So right, you call this load state function, which does the actual mem copy. So if we come here, it goes through all these blocks that we saw in memregions.h, and internally, it just does a mem copy.
Right. Okay. Sorry, I mixed up a little bit because I forgot that all of this save state restoration code is on Dolphin side. The game doesn't
Ah,
do any
yes,
rolling back at all.
right,
It just
right.
keeps simulating. Right.
Yep.
Yep. Thanks for clarifying that.
Yeah. Train of thought. Yeah. So we get the number of frames to simulate, and then we jump in here and we call gameproc. And gameproc is generally the function that simulates a frame for the game. It does a bunch of stuff up here. This is important in a second, but I think these calls at the bottom are the most important. Because I think most of Brawl operates on this task scheduler thing, where individual like classes or parts of code can create their own GF tasks. I think GF stands for like a game frame or something. I don't really know entirely. I think that was Fracture's name for it. But they register their own callbacks into this task scheduler, and then the task scheduler just iterates through all of them and calls it. Uh, it's basically just a huge linked list of a bunch of them where you can add and remove your own callbacks, and then there's the loop. Here's the call. Yeah.
Cool. I was wondering about some of that stuff when I was digging in for the replay menu stuff. So
Yeah.
that's cool to see that.
So I think this is where most of the processing actually happens. And then I think this does some stuff with the scene. I don't really know what that means. File IO modules. I don't really know what most of that stuff is. But yeah. But importantly, before it does any of this, the main meat of the processing, it calls this update IP switch, which is a pretty important part of the input flow, I guess. What I mean by that is like how inputs come from being pulled from your controller to being processed to being used in the game to update the state of characters and stuff like that. And this is also where we happen to do some hooking, I think. Let's see if I can find that. Get gamepad status hook. Yes. So right here we see it says get gamepad status. And what this does is it takes, so let's see if I can explain it properly. Brawl has a thread that runs in the background that will pull the status of your controller for on some interval. I don't entirely know what the interval is, but it pulls it pretty consistently. And at some point in the frame, it'll take those pulled inputs and convert them into a GF pad status struct or something like that. And all that this does is it gets that pad status from whatever buffer holds it and copies it onto the stack, which is this current inputs thing. And we, right here, hook inside of that. I don't know if this will line up. Maybe it will. Yeah. Okay, so I hook right at the end of this get gamepad status, right in this LI before the BLR. And in that, I do this inject to game thing. And all that does is similar to the populate frame data, which takes information from the game, puts it into our own data structure so that we can pass it around and deal with it. But inject to game takes a frame data and puts all that data back into the game. So this stuff's commented out, but this one's pretty important, where it takes a GF pad called GameCube, but it's basically the GF pad status that we saw in here. And it simply copies it over. It copies all the stuff in the pad that we provide with, it copies the stuff in the pad we give it to this pad that we provide it, which in theory is the game's pad. Here. So that's where we actually put inputs from all the processing and shit that we've done, and this is the line where we put it back into the game. That's kind of the TLDR of this specific section. But the other section that is important is this one, which happens at the beginning of, actually I can just jump to it here. So we said that the other hook was in here. So right in this function, this is where we inject our inputs. But we're going to need to do more processing, right? Because in the pre-frame hook that I explained earlier, we only store and send inputs. We don't do any other processing with it. So right up here, I have one more hook, which calls this process game simulation frame, which saves the state of the game and then requests inputs from the emulator. It'll send up a little command that says, hey, I want frame data for this frame that we're passing in. And then it'll read in the response into whatever this is, and then fix the endianness. And this is where the meat of things happen. Right here, handle frame data request. So the data, which we saw, right, it's just the frame. So this slippy utility thing that reads word, it also flips the endianness properly. So this just has the current frame that the game is requesting from the emulator. So what I do is I make a frame data, I go through all the players, and I get the remote inputs, and I also get the local inputs. And I package that up and then send the frame data back down to the game so that the game can then where am I? Process game simulation. It assigns it to current frame data, which is just a global, a static global, and it then uses that to inject into the game. I went pretty fast, and I also kind of went out of order, so I get that it might not make a lot of sense, or maybe it does make sense, and it's just kind of overwhelming, but...
No, it makes sense
Yeah.
to me, and everybody's watching this, they can re-listen to parts. So frame data is like just inputs, basically.
Yeah, it's just an array of player frame data, which is just...
It's the information that's needed to re-simulate frames.
It is the information that is relevant for each character. But basically, you can think of it as just having inputs,
Right.
which is this pad
But
thing, which is just buttons, your stick positions, your trigger positions.
this is the data that we have for each frame in order to do rollbacks, right?
Yes,
Or to
yes,
do
that's correct.
resimulations frames. Okay.
Yep. Ooh. So yeah, if you want to really get into some of the rollback stuff and figuring out like exactly how the logic works, all of it happens when we get uh when we get remote inputs. So you can look at all this stuff. Um, if someone's watching and has questions about it, feel free to ask. I'm more than happy to explain. I get that it's kind of confusing and weird, but at the end of the day, it's not a whole lot of code, and it really isn't as complex as it might seem once you spend a bunch of time with it, as all things are. So yeah, that's, I think, pretty much all I wanted to say about input flow and stuff. It's just kind of I guess the TLDR is that the game requests information from the emulator, and the emulator does processing and then gives the game back exactly what it needs for that frame.
Yeah, and we didn't go over all the EXI stuff and how that works in this
Yeah,
discussion, but
there's a
yeah.
there's a video from Fizzy where he explains EXI stuff. It's this one, if you guys want to know. If you want to learn about like what the heck, where is it? About like this stuff, this EXI commands and how the game can communicate with the emulator.
Mm-hmm.
He does a pretty good job of explaining how that kind of stuff works here. So I would recommend watching that.
Yeah, I think the important thing that is maybe not obvious from looking at the code is that the EXI stuff is totally like synchronous. So on the game side, when you write EXI to say a command, you can read back right away, and you know that the emulator has already responded to
Yep.
that request. So I think that's just again a good thing to note, I guess.
Yeah, that's a great point.
So it's like a remote function call, basically.
Yeah, yeah, that's exactly what it is. I would definitely think of it like a function call. When you send stuff up, you can send it with some information, basically like sending a function with arguments, and then you can return stuff from the emulator back to the game.
Yeah, just like a TLDR on it, I guess.
Yeah,
But
that's
the
a good
video's pretty
explanation.
good.
Yeah. Cool. Okay. I don't think I have anything else I want to say on that. I talked for a while and I talked fast and it felt nice. I think the only thing I want to talk about is having two dolphin instances, because when you first start to try and set this stuff up, it is weird. So if you do want to set things up, what I would recommend doing is cloning from the where is it? There it is. From the Brawlback repos, you'll want Dolphin and you'll want the Brawlback ASM. You'll also want, when you clone them, to clone them with submodules. If you're doing it on the command line, I'm sure you already know how, but it's, submodule and init recursive. You can look up submodules on the internet. There's tons of stuff about that. But these are really the only two ones that you need for building, I believe. And building the Dolphin fork, there's a whole bunch of README stuff here. It's just building normal mainline Dolphin. There's not a whole lot else I can say because they already have steps for everything. So just follow those. And for building the ASM repo, though, I think this stuff won't be here, or a lot of this stuff won't be here because this is some of my build system. But there is a video somewhere wonder if I can find it right now. I don't think I can. But
Which
if you,
video are you looking
the one that White made about setting up the ASM repo and stuff.
Yeah.
Anyway, you could probably just join the Brawlback Discord and ask for it. I'm sure it's pinned somewhere. If you really want, that's it exists, and that kind
I
of
just
tells you. Oh,
posted
there
it
we go.
in Dev General.
Here's the video. Maybe you can look that up, but it's definitely in the Brawlback Discord somewhere. That explains how to set things up, but in terms of having 2 Dolphin instances, there's a little bit more you have to do. So if you have the ASM repo building and the Dolphin repository building, what you'll want to do is you'll want to come into the Dolphin repository into the folder. If you've built Dolphin before, then this binary folder should be here, and you probably will just have this x64 thing. So what I would do is I would literally just copy x64. It's gonna take a while, so just kind of pretend that happened. And then you have this x64 copy. You want to go into it, and yours won't look like that, but you will want to go into this x64. You want to take this portable.txt, or if it's not there, you can literally just make it. It's a blank text file, like that. Make that portable.txt and then run Dolphin, and then this user folder will pop up. And you're going to have to do a little bit of configuration with the build system. I don't actually know about what the mainline build system is using for the Brawlback repository. I guess I can look at it right now. I assume it uses this thing, which is main.bat. Let's make builder something. So I don't think the build system that's in here currently supports having a second Dolphin.
So we don't have scripts in there for a second Dolphin, but I was able to like copy some scripts from your repo into my folder, then use them.
I see. Okay, cool. So we might end up changing this at some point. So if someone's watching this in the future, maybe things are different and it's a little better. Feel free to ask in the Discord if you're confused or don't know what's how to do it. But at least on mine, I have this little ini thing with a bunch of variables, and I also have this secondary exe thing and this binary stir. But the general gist is that when you're doing networking testing, you'll need to have 2 Dolphins open at the same time. They have to be of different like folders here in this binary. They have to be different copies of all this shit, and they have to have the portable.txt, which has a user folder, because in this user folder, if you go into we, you'll see the st.raw, and the st.raw contains all the code for this game side stuff. So whenever I build, you can see my script first builds Dolphin. And of course it takes a good second or two, because Dolphin's big. But after it builds Dolphin, it'll hop over to the game and it'll build the game. And once it builds the game, it'll end up taking the built files from the game and kind of packaging them up into the SD card, the sd.raw. Does a whole lot of stuff. Here we go. So it builds the mod files, and then it takes the mod files, and it does this, but it shouldn't do that. I don't know why it's doing that. Actually, I might know. do we have? No, we don't. Oh, okay. I don't know why it's saying that. That's a little cringe. Anyway, when this works, it should copy the relevant files that get built for this code into the sd.raw. And then I have a batch script here that just copies the sd.raw from my main Dolphin instance, which is this x64, to the secondary instance. And it does the exact same thing with both the sd.raw here and also the dolphin.exe. See, there's the dolphin.exe, there's the sd.raw. It also does the same thing with some like symbols map stuff, which is debugging things, but that's not as relevant. But I believe the only two things that you really need to maintain, to make sure that your secondary and your primary instance are synchronized, are the dolphin exe and the sd.raw. Because if they're not synchronized, you might build some code and it might run and build on your primary instance, but then not on your secondary. Your secondary might be running older code and then things don't work and you're confused and it's weird. So you want to make sure the exe and the sd.raw are the same on both of these. And then I have another batch script which just runs. Where is it? There it is. No. Where am I? Run. There right here. Which just does this little command, which runs Dolphin, and you see the -d that I mentioned way in the beginning, runs Dolphin in debug mode. And it runs two of them. It runs this one, and then it runs this other one with a secondary thing, which does this. Make sure you run the secondary exe. So basically, there's a whole bunch of batch scripting stuff, and at some point in the future, maybe there'll be a tutorial or some kind of nice README that you can read about for building and how to use the build system and how to run things and all that. But yeah, you'll want to have two of these Dolphin instances, separate folders and shit, but sync up the exes and sync up the sd.raws. And that's about it. If you run both exes, they'll both launch, and you should be able to matchmake into yourself if you have lilat.jsons for dev testing, which you can get from Repito, but that might not. I don't know if he wants to just keep giving those out, actually.
I thought there was a way to matchmake locally without needing to connect to any server, but I'm not.
I think there is, but I haven't used it. So if you define local testing, this might just work, but also be aware I haven't ever used the local testing stuff. Well, I have. I wrote some of this code, but I haven't used it in a long time, so I don't actually know for sure if it fully works. Apologies. But yeah, you could try and use this local testing thing. Otherwise, maybe I just ask in the Discord, see if you can get a lilat.json, which has some like dev credentials, just random testing shit. Yeah.
Repito replied in the Twitch chat.
You can create a dev user with a random email. Ooh, sweet. So do you mean like, where am I? Right here. Here. I mean, you can just use these credentials, but with, like, what do you mean? Do you mean like going on Lilat and making an account? Maybe that's what he means. Maybe just do that. Make an account. Grab your... Oh, never mind. But that's kind of the gist of testing rollback stuff. Make sure you have two instances, make sure they're synced up, and then matchmake against yourself or connect against yourself locally with localhost. I mean, like creating a new account you will use for testing. Yeah, okay. Oh, yeah, yeah. So literally just going on lilat.gg and making a new account, registering, and then grabbing the lilat.json from that account, which here, actually, I'm going to try and do that right now. Display name. Yeehaw. Can I leave this blank? Or do I have to put in, maybe I just put in like a random email. I don't know. Anyway. I think that's about all I have to say. Is there anything else that you think I missed or that I should go over or anything like that?
Not that I can think of. Thank you so much for going over all this, though, especially the safe state stuff. I feel like I understand a lot better what's going on there.
Yeah,
and anybody who watches it.
It was a lot of information. So if there is any other things that arise, feel free to let me know. I will always respond and be happy to help.
Oh yeah, I'll be on the Discord.
Yeah. Well, yeah, I'm excited. That idea of running the script for things that didn't change is very interesting. I feel like that's a pretty solid way forward, or at least that maybe another thing we could do to get slightly more information.
Yeah.
Just
I have
generally
some ideas around.
changing the script around and working with that idea, I think, is pretty cool. What's up?
I kind of want to tackle just refactoring the memory regions code, or sorry, the save state code in Dolphin, because the data structures are kind of like maybe more complicated than they need to be, and there might not be as cache friendly as it could be. Because if the bottleneck is like just copying data from the emulator, but we're copying it into like a bunch of different heap allocated buffers, and I don't know, maybe that just wasn't a problem for Slippy, but for us,
that's
we
a good
might
point.
need to do things.
Yeah.
So I don't know. Kind of. Maybe I'll take a look at that.
Yeah, absolutely. Please do. There's the all the save state, like the actual saving and copying stuff, just happens in save state CPP.
Yeah.
And I'd also think I might look into a little more later of multi-threading some of it and trying to just split up the chunks. I remember I did that a while ago, but it didn't help performance
Yeah, I was
at all.
talking to Wade about that a little bit on Discord, and like, is it even? Can you even thread safely read from the GameCube or the Wii memory?
I would say
Like,
yes, because
I guess the emulation's not running, so
right, because we do this thing. So the Wii was single threaded, and so it used processor interrupts to kind of simulate threads where it would switch between contexts really fast and make you feel like there was multiple threads. But you can totally disable that, and I do that for pretty much all of my hooks, where we disable interrupts at the beginning and then re-enable them after. So when we call functions that go into the emulator, it's pretty much guaranteed that there won't be an interrupt, and it's guaranteed that we'll kind of just stay in this. So I think it is thread safe because the memory won't be changing.
right.
I suppose.
What's up, guys?
Oh, hey.
I figured I'd just join in because Pine's not reading his chat messages.
I'm so sorry.
Yeah, just wanted to say that I'm looking forward for the BOD.
Oh yeah.
Because I missed the first half, and in regards to what you were talking about of the save state stuff.
Yeah.
I don't know if you already tried disabling music because that will help you find far less memory regions that you need to account for, because memory changing or not changing from one frame to another it's increasing size, so it's probably making the diffs bigger than it should be for what you're looking for in terms of optimization.
Yeah. Oh, that's a good point. I haven't looked into music stuff at all, but that is probably something that we should do. Is like fully disable it from a code
Yeah.
standpoint.
At least for the first like just at the beginning to make like to try to find just the most important stuff that we need, and then we can enable it after we get to a place that we're happy with.
Yeah, absolutely. That's a good point. So maybe I'll look into that. I don't know. Maybe possibly.
Yeah, wouldn't the music stuff be all in like one audio memory region?
Like an audio buffer.
No.
I would feel like it
Who
would
knows?
be, but yeah.
Who knows? Yeah,
Who fucking knows?
That's a good answer.
Like that depends a lot on how it was coded. Like if they are using some static variables to keep track of it, like in a global state, or if it's just on the heap at some point, or even both of them at the same time. Like, and what if they have some specific things tied to network code that is also shared for offline, and it's duplicated? Like it's
Yeah.
it can be like anything.
Cringe. Cringe and weird. Who knows? Well, that's true. We do know that there is that one heap region that just is sound. So they almost certainly keep some stuff in there. Who knows? Anyway, is there anything else I should go over, at least on stream? I don't really think so.
Yeah, not that I can think of.
Sweet. Okay, cool. I'm gonna end there. I might try and put the VOD up somewhere.
Yes,
Yeah.
please.
Hopefully it'll be on a YouTube channel. I don't know. I'll figure it out.
Yeah.
See
We
you
should.
later.
One thing that would make the VOD a lot better would be to put like chapters or whatever in YouTube.
Oh, true. That's a great
Just wanted
point.
to mention that. Maybe if
I guess.
Joe is planning on watching it, he should.
Yes, I guess that Nova. I will assume that Nova would love to do that kind of stuff. I think they already set up the YouTube accounts.
Yeah.
Sweet. Then maybe we'll do that.
Yeah, I'm just thinking in terms of gathering the different relevant sections and timestamps. It might be like if you were planning on rewatching it.
Yeah, that'd be super helpful.
Because even like I don't know, it might be harder for Nova to figure out like which parts are logically grouped together. I don't know.
True.
Technical experiences.
All right. I'm gonna end stream there.
All right. Thank you.
For anyone still tabbed in, appreciate it. For everyone else, see ya.